Hello world and welcome back to Monty Makes Games. In my previous video I talked about swapping out characters mid-animation using Unity's Sprite Library and the Sprite Resolver. Well, somebody asked me, can you do this with traditional frame-by-frame animation? I had to scratch my head a bit, but the answer is yes. I'm going to show you two methods on how to do this today, and then we'll talk a little bit about the pros and cons of each. Let's get into this. My name is Mani and I make games. Let me give props here. The character that I'm going to be using today is something that I got off OpenGameArt, and I'll link it down below in the description. Also, if you like what I do, why not hit that like and subscribe button, and maybe even ring the bell so you know when my next video comes out. But enough of that, let's talk about how we animated these two characters. The first character on the left is animated using Unity's frame-by-frame animation system with the traditional Unity animation system. The other one is a roll your own kind of animation. I'm going to go over this one. It's a little more tricky and I don't think it's quite as versatile as the Unity solution. But let's have a look and you can decide for yourself. So, why do we need to bother about this and why is it tricky? Well, let me show you. In traditional animation, if we do a frame by frame, we would just basically start recording. Let's create an animation there. I'll call it new animation, which is very unimaginative, but also we'll be deleting it soon, so don't worry. Then we would go record and we would basically either drag our sprites in here like this, which would work, but then we couldn't change the color to our other sprites on the fly, which we want to do. So let's delete this and try something else. We've got a sprite resolver, right? So we'll record and then we say sprite resolver over here, and we'll just change the label on each one. So let's go label 1. It records it 3 and so on and so forth. I'm not going through a lot of trouble here right now, as you can see. Whoops. Let's move our keyframe over there. Now, as you can see, it basically directly references. Let's just move this out of the way. As you can see, it puts a number in here which is called the sprite resolver hash. Now, the problem with this is it's not actually the sprite resolver label. So when it references the hash, it actually references this sprite or this sprite specifically, and not the label which tells it which label to use for that sprite. So when you would run this animation in the game, you would actually end up with a situation where it would just show the sprite that you selected with the hash and not actually the correct version for the category that you're in. So this makes it a little more tricky. In the old version of Sprite Resolver, which was around, I think, version 2, you could actually reference the label directly and this would have worked. But this is not working for us, so let's delete that character. and see what works. My first instinct was to just script this, and like I said, that works, but it's not quite as flexible. So let's have a look at what I came up with. Well, here we've got our character. He's set up with the sprite renderer and the sprite library and the sprite resolver. Then I've got the script called sprite swap animator, which I'll show you in a moment. But before I show it to you, I just want to show you what the library for this looks like. There we go. Here's my library up here. Now you can see for each animation I've created a label, and the labels are numbered. So I've got jump 0 for the first frame for my jump, jump 1, jump 2, jump 3, and so on. And we have to do consistent labeling, of course, across categories. When we get to the script, you'll see why this was important to us. In the script, we are going to be basically manually swapping those out at the rate that we want to. So we set our frame length and everything, and actually manually swap out the labels on the sprite resolver. So what we've got here is we've got a serialized field called switcher animations, or animations actually, and that is of a special class that I've created down here called switcher animation, which basically just has some public properties. It's got a label prefix, so for the jump animation that would be jump, and then it's got number of frames, that's how many frames there is in that specific animation, and we've got loop animation, which is set to false by default. Loop animation is going to tell us whether or not this animation should run on a loop or not. Then over here we've got an array of character names which we'll be using to switch between characters, and we've got frame length. This is going to be how long each frame is displayed before we move on to the next one, i.e. short frame length, fast animation, long frame length, very slow animation. And then we've got our sprite resolver, which we just drag in there, and a boolean to keep track of whether or not we are currently animating. Why do we do this? Because we'll be using a loop, a while loop, and we want to be able to fall out of that while loop without any trouble. Then we've got the frame index, keeping track of which frame of the animation we're on, and we've got our character index, which tells us which character we are supposed to be showing. And then here we've got our current animation, which is of the type switcher animation, which we talked about earlier. We've got an enum called state, which is just basically the different states or animations actually. And we've got a current state which keeps track of which animation state we are currently in. If you use the Unity animation system, all this and more are actually given to you out of the box. Now, on enable, we're just basically making sure that our current animation is set to the first one in our array. We're setting is animating as true because we want to start animating immediately, and we start our coroutine. The coroutine defines the label which we'll use as the current animation dot label prefix. So if we're in the jump animation, that's basically just going to be jump, and add to that the number of the frame, which we determine by taking the frame index modulo the current animation's number of frames. We've talked about this trick in the previous video, so if you're unclear, just go back and have a look at that. You can also look up the modulo operator. Then we just set the category and label on our resolver. resolver.getCategory is going to give us the category that it's in right now, so we don't change the category. And then of course label over here is going to define which label, or should we say which frame of our animation is going to be displayed. Then we just yield return for however long our frame length is set. We increment the frame index, and then we do a check. This basically just says if our animation's not set to loop and our frame index is the same as or greater than the last or the number of frames, so we're on the last frame of our animation, then we should switch to animation. Now, as you can see, I've hard-coded switch to animation 0 because we want to keep this one simple. So it basically just goes back to the idle animation, and the only other animation we have here is jump, which I've set to go to when we actually press the spacebar. Switch animation down here basically does what I said. It resets the frame index to 0. So it's a new animation, we're starting from scratch, or from frame 0, should I rather say. And we're taking our current animation and setting that to the new animation according to the index passed in over here. On disable, we're just setting is animating to false to drop out of that loop. So if our game object gets disabled, it doesn't stay in the loop. And then in update, we just check for some key presses. So if we press spacebar, we're just going to go to our switch animation, animation 1, which we know is jump. Not great practice this, but we're keeping it simple for now just to show the principle of the thing. If we use S, which is for switch, it's going to go character index plus plus, so basically increment the character index, and then the name of the new character is going to be determined by taking character names and using that character index, again using the modulo trick just to keep it in range. And then I've got a little debug statement down here just to help me check things. And that's about it. So that's a frame by frame animation using a script and managing the state with the same script as well. This can work, and yeah, it can work quite well, but it needs a lot of work and there's no safeties on this at the moment. An easier way would be to leverage Unity's animation system and just do a little tweak to make it work. So let's have a look at how that would work. Let's do a little demo of our character before we move on. The character we're looking at is this one on the right. Now you'll see the character is going to start in his default animation. I called it idle, but it's actually more like a run. And then if I press S, it will seamlessly switch to the different character. In this case, I've obviously used the same character because the animations needed to be matched. But you can imagine this changing to, say, a werewolf or whatever you wanted to. Okay, and if I press space, our character does his little jump thing. And of course, you can see my character on the left reacts as well. Now let's look at how this one is set up. This would be the way that I recommend. If we go down here, the character is set up with an animator this time because we'll be using Unity's animation system. And it's got the FF animation script, which I'll show it to you now. And then the normal sprite library and the sprite resolver. Now the sprite library for this one's different. Let me show it to you. I've still got my categories for my different characters, and then I've just got my label set up with numbers over here. Now let's say we want to set up an animation for jumping. We could go in here and we could check this out and say, okay, the jumping frames we want are over here. So let's say we count that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's say we want to use these for our jump animations, and we note them down. And our run animation, we could use 27, 26, 25, 24, 23, 22, 21, 20, so 20 to 27. If we know those numbers, we can now proceed with setting up. Now here's where the trick comes in. In our script, FF animation, we basically have one public function, and that public function is just change label. So it takes the label, we feed it. It says to the sprite resolver, set category and label, and then the sprite resolver keeps its own category by calling sprite resolver get category, and the label is set to whatever we supply. We'll look at the rest of this code now, and you'll understand why it works. Then, when we create our animation, let's say I've got my hero animation, which is set up here. I would click to add an event to the frame that I want. Notice that I didn't have any other properties set up down here. Then when you click on the event, here you set the function to that FF animation, and the method you want is that public change label method. Now what string are we passing in here? Well, that's the frame we want. So for this, we want frame 2, which would be 0, 1, 2. This one over here, that's probably going to be our idle. And then the next one, you can just go Control C and Control V over here, and then just change the number to your next frame. And that way you set up your animation as you go. Now just to quickly explain what the rest of the script does. End start, it just grabs all the components it needs, so the animator and the sprite resolver. And then an update, it looks for keys. So if we press B, it's going to switch to our blue character, R for our red character. We could have done the logic so that we press S and just switch between the two as before. And then space is going to do jump for us. And if I hold down the right arrow, when it goes down, running, the boolean running on my animator is set to true. And if I let go, running is set to false. And that basically just controls the transition from the running state to whatever other state I have. And then in the animator, using Unity's animation system again, which does a lot for us, I've just set up my different animations with transitions. So I've got my entry going to the hero animation, which is basically our hero standing there and doing his katas. Then I've set up a transition. This transition happens when running is true, and when running changes to false, it transitions back. And then here I've got my hero jump, which can come in from any state when the jump trigger is activated. And then immediately when the jump is finished, it transitions out to run, and if running is actually set to false, then that will automatically transition to the idle pose. I'm not going to go into setting up animator and transitions in detail here, but if you would like me to do a video about that, then let me know down in the comments. So, to play us out, let's look at the left character and see how this works out. And there we go. So our animated character on the left is currently in its hero animation. And if I press jump, transitions to jump. When it's finished jumping, automatically it goes back. And if I press the right arrow key, it starts running. I press jump, lands, keeps running. And if I let go, goes back to doing its really weird kata. That's it for me. Until we see each other again, my name is Mani, and I make games.